So our goal here is to apply some new order of operations to numerical expressions. So just a quick review, good old Aunt Sally here. If you please excuse my dear Aunt Sally, that's a good way to remember what to do if you have a bunch of operations in one little expression, in one little group, in one problem. If you do parentheses, if anything's in parentheses, you do that first. If you have any exponents, you do that next. If you have any multiplication or division, you do that third. And if you have any addition or subtraction, you do that last. A few things about multiplication and division. If you have more than one multiplication problem in one problem, like multiplication and division, so you may look at this and you're like, well, I know I am supposed to do multiplication and division first, but does it matter if I do the multiplication or the division next? You just go from left to right. So I would do, if I'm going to not do the addition yet because that comes after multiplication. But I am going to do my 12 times 6, and then my whatever I get there, I'm going to divide that by 2. So 72 divided by 2 gives me 36, and then I can go to the addition part of the PEMDAS, so please excuse my dear Aunt Sally, the order of operations, to get 42. The same thing happens with addition and subtraction. Notice I have a subtraction first here, and then I have addition next, and then I have multiplication. Now obviously you're going to do your multiplication first, your 2 times 6, because please excuse the multiplication part and division part comes before addition and subtraction. But now I'm left with, I did 2 times 6 to get 12. Now I'm left with 18 minus 3 plus 12, and I got to figure out which one goes first. Well, with addition and subtraction, you don't necessarily do addition first. You just do what comes first between addition and subtraction. So in this case, subtraction comes first. So I'm going to do 18 minus 3 to get 15, and then I'm going to add my 12, which is going to give me 27. So if we did addition first, this would have been 3 plus 12 to give me 15, and 18 minus 15 gives me 3. We would have gotten a completely different result. So if you have multiplication and division, after you get through your parentheses and exponents, do whichever one comes first, multiplication or division if you're working left to right. And then if you have addition and subtraction and you've already done your parentheses, your exponents, your multiplication and division, then do your addition and subtraction, but do whichever one comes first. It might be subtraction first if that's first in line like we did here. So sometimes we can take the order of operations and take a problem that's multiple steps and make it one expression or one equation out of them. And just in case you're wondering what the difference between an equation and an expression is, an equation is anything that has like a relation symbol. It's usually an equal sign, but if you have a greater than or a less than, that's an equation because you're showing that both sides of these things are related. In this case, they're equal to each other, or you might be saying one side is bigger than the other, but you're showing a relationship between two sides. An equation is also known as a math sentence, whereas an expression is only one side of equation. You're not comparing it to another side. You're not saying it equals something else. You're not saying it's greater than or less than something else. It's just one side of an equation. So it's also known as a math phrase, and this is going to be crucial when you get into algebra. And you'll see when you start working more with variables and letters and solving expressions and equations. But I want this vocabulary to be kind of familiar with you now. To know an equation, you have some kind of relationship symbol between two sides. Either one's greater than the other, one's less than the other, or both sides are equal. And then an expression, it's only one side of the equation. You don't have two sides that you're comparing or setting equal or making greater than or less than. So with that in mind, let's make one equation out of a simple word problem. Steve puts $25 in a magic box. It doubles overnight. He even finds $10 on the street the next morning, and he wants to split the money evenly between 3 friends. How much will each friend get? So before we make our equation, there's a couple expressions we can make out of this. I know his $25 is going to double, so I'm going to have to do times 2. But he also finds $10, so he's adding 10. And he wants to split the money between 3 friends, so he's dividing whatever the result of that by 3. So I could do 3 separate problems, 3 separate equations, but what I want to do is using the order of operations, put this into one expression. Okay, so I did 25 times 2 plus 10. Now the reason I put parentheses here is because I don't want to just say plus 10 minus 3 without parentheses, because then I'm going to multiply 25 by 2 and then I'm going to do 10 divided by 3. I don't want to do that. I want to keep this result all together and then divide it by 3. So are there any other expressions that we can make? If I were to turn this into an actual equation, 25 times 2 plus 10 divided by 3, 25 times 2 plus 10 divided by 3. This by itself is an expression, but if I wanted to find out, well, that's the same thing as what? If I wanted to make it equal to something, I would say 25 times 2 gives me 50 plus 10, and then I divide that by 3. And then my next step, I would say 50 plus 10, I'm still in my parentheses, 60 divided by 3. And then I would simplify that even further. 60 divided by 3 is 20. And so what you could say is 25 times 2 plus 10 divided by 3 is the same thing as 20. These two sides are the same. Now normally we would just say, oh, equal means the answer. But we're saying that these two sides are equal to each other. They're the same thing. So this would be the whole equation. And this just by itself would be the expression. Maybe we could have made a few other expressions out of this one. And this is just one of the ways you could have done it. So you try this one. George has 15 jelly beans and he ate 5 of them. He then used the magic box that his buddy Steve had and put his jelly beans in there. There's some weird glitch, and now there's half as many as the next day. Didn't work out for George like it worked out for Steve. But he ate 3 more to soothe his sorrows. How many does he have left? First, I want you to try to solve... Whoops, I showed you part of the answer. I want you to try to solve it. Try to figure out what are you doing in the problem, what operations are you doing, and then try to put it all in one expression instead of having 3 or 4 different equations or something like that. One expression. So give that a shot. And then come back. Pause it if you need to. Okay, and we're back. A few different ways we could have done it. We said he had 15 jelly beans and he ate 5 of them. So I'm going to say 15 minus 5. That's the first thing I have to do. But then he used the magic box that his buddy Steve gave him and put the jelly beans in there, but there was a weird glitch and he has half as many as the next day. So 15 and 5, whatever that result is, I need to divide it by 2. So I put that in parentheses because I don't want to, if I don't put it in parentheses, that means I'm not going to do the subtraction first. I'm going to put that in parentheses and say the result of this, I need to divide that by 2. And then he ate 3 more the next days, and how many does he have left? So whatever I do here, I need to subtract 3. I could put parentheses here. This 2 shouldn't be here. I could put parentheses around the 2 and the 15 and just have 2 layers. But since I have to do division before subtraction anyways, it's not going to change my result if I put parentheses there. So in this case here, it's another way I could have written it. I could have said 15 minus 5, the 15 jelly beans he had minus the 5 that he ate, and then take that answer and divide it by 2. It looks like a fraction, but that's one way that you can show this division right here. And then this whole result, I would then subtract 3, and then that would give me the result of 2. So there's a couple ways you can do it. We haven't worked with this second one much, but I want to show you that division can be written as a fraction when you're writing an expression. Okay? So that's what we have so far. That's taking order of operations and kind of applying it to word problems. Go ahead and give the practice a shot and let me know if this is not making complete sense yet.